Hello everyone. Today we are going to see part 5 of reagents in organic synthesis. And in this part, we will deal with 1,3-dithiones. And here we will see Umplong concept, reaction with alkyl halide and acyl halide. The heterocycles carrying two sulfur centers, bis sulfides in cyclohexane ring are called dithions. So there are different dithions. Here, this is cyclohexane ring. This one is another cyclohexane ring. If this is S, two S are adjacent at 1, 2 position, 4, 5, 6. Then this is known as 1, 2 dithion. This is 1, 3 dithion. And if two sulfurs are present on 1, 4 position with respect to each other, then that dithion is known as 1, 4 dithion. So these are the isomeric forms of dithion: 1, 2, 1, 3, and 1, 4 dithions. So our interest is in 1, 3 dithion here. This 1, 3 dithion formed by refluxing for over 8 hours a mixture of 1,3 propane dithiol. This is 1, 2, 3. 1,3 propane dithiol and dimethoxymethane in presence of Lewis acids such as BF3, diethyl ether, heating, acetic acid, and chloroform. With constant and vigorous stirring, we get 1,3-dithion. Aldehyde or ketone readily forms 1,3-dithions by reacting with 1,3-propane dithiol in presence of BF3 diethyl etherate. So here this aldehyde when react with 1,3-propane dithiol in presence of BF3 etherate, we get 1,3-dithion. Dithions forming lithium derivative and anion. This reverses carbonyl group polarity. We mean carbon acquire generally carbonyl carbon is delta positive and carbonyl oxygen is delta negative. And if at all we want to place any electrophile on this carbon, this reaction is not possible in carbonyl compounds. But when we use 1,3-dithion, we can reverse the polarity. That is, carbon can be converted as delta negative or electron rich center, and this can be attacked on the positively charged electrophile. So, how this is happening? The reversal of polarity of the carbonyl group. This happens like this. When 1,3-dithion reacts with butyl lithium, it can abstract this proton, and we get as this is the butyl lithium is a strong base, it can abstract the proton and we get the carbanion here. And this carbanion further attacks on the alkyl group of alkyl halide, and halogen X minus is removed, and we get this alkylated 1,3-dithion. This alkylated 1,3-dithion further can be converted into lithium derivative by reacting with butyl lithium. As this is the strong base, it can abstract this proton and we get carbanion. And this carbanion plus Li plus, this is lithium is coordinated with this carbanion and this is known as lithium derivative. Either you can show this bond or this bond. If you do not show this bond, it is also okay. Carbanion C minus and Li plus. And this carbanion is further reacting with electrophile and we can attach this electrophile with this carbon. After this substitution of electrophile on the place of this hydrogen, we can further hydrolyze this intermediate and can be further generation of carbonyl compound is achieved. So here first reaction is abstraction of proton and generation of carbanion. Then second step is attack on the new electrophile, and in the last step hydrolysis with the help of HGO H2O THF, and finally generation of carbonyl compound. So we can generate the carbonyl compound in the final step, but that is substituted carbonyl compound. So polarity inversion allows carrying out secondary reactions of functional groups which are otherwise not possible. Thus, this aldehyde, if directly we want to have this electrophile on this carbon, it is not possible, as this electrophile is electron deficient and this carbon is also electron deficient as it carries delta positive charge. And this electrophile substituted derivative cannot be achieved by this step. But when we go via 1,3-dithion, then we can achieve this target molecule. So aldehyde or ketone is reacted with this 1,3-propane dithiol. 1,3-dithion is generated. This 1,3-dithion after reaction with base can be, this proton can be abstracted with the help of base, and this negatively charged carbanion further attacks on the electrophile. This electrophile forms bond with this carbon and further hydrolysis regenerates the substituted carbonyl compound. And this 1,3-dithion find widespread use as a standard tool in the hand of synthetic chemists. Omplong is useful to prepare a wide range of products that cannot be obtained using normal reactivity. The reactions illustrated below highlights Omplong and reversal of the polarity of 1,3-dithion in organic synthesis. Here, same reaction is shown how this butyl lithium extracting this proton reactant with alkyl halide, then further reaction of butyl lithium with this 1,3-dithion abstraction of this proton and generation of negative charge and further substitution of electrophile and hydrolysis regenerating the substituted carbonyl compound. Here, synthesis of ketone and aldehyde is the important use of 1,3-dithion. 1,3-dithion, when reacts with butyl lithium, it can abstract one of the hydrogen from this two hydrogens. And here carbon will be negatively charged and lithium will be positively charged. It can be named as 2-lithium-13 dithion. When it further reacts with carbonyl compound R and R, this negatively charged carbon can attack on the carbonyl carbon and we get the intermediate. This is here O minus will obstruct proton and we will get OH. This is the structure is like this O R R and this one will be H if the detailed structure is drawn. And hydrolysis gives us carbonyl compound after reaction with HgOH plus. This can be used for substituted formation of substituted aldehydes and ketones. 1,3-dithiene reacts with butyl lithium, forms lithium salt, and this reaction of alkyl chloride with this lithium salt gives us substituted 1,3-dithiene and substitution of alkyl chloride takes place on the place of this carbanion. And hydrolysis gives us the substituted aldehyde. But hydrolysis with after reaction with methyl cyanide, we get substituted aldehyde. Similarly, we can prepare beta hydroxyketone by using ethylene oxide or epoxide. This is ethylene oxide or epoxide when reacts with alkylated 1,3-dithiene, uh, sorry, anion of 1,3-dithiene. This butyl lithium, first of all, removes the proton and here generation of negative charge. This will attack on the carbon of epoxide. This ring opening takes place and we get this intermediate. Further hydrolysis gives us this beta hydroxyketone. By suitably selecting alkylating or acylating groups, a wide variety of compounds like aldehyde, ketone, especially 1,2-diketones, alpha hydroxyketones, alpha keto acid derivatives can be prepared. And here, this 1,3-dithiene reaction with butyl lithium generating lithium derivative can react with alkyl halide. Here, all these steps are hydrolysis steps. Only the difference is alkylating or acylating agent. When we use alkyl halide, then we get ketone. Substituted epoxide can be used to generate alpha beta beta hydroxy ketones. The ketones can be used to to generate alpha hydroxy ketones. Acyl halides can be used. This X may be Cl, Br, I, etc. Any halogen. So acyl halides can be used to generate 1,2-diketones. Similarly, this salt can be used to generate the secondary amino derivative. Thank you.